Problems facing by the blind and how many blinds are in the world.
Blind and visually impaired people encounter many obstacles as they navigate public spaces. Everyday situations, for example a trip to the bakery or the doctor's, are much more challenging for them than for people who can see.
Ich bin von Geburt an sehbehindert gewesen und die Augenkrankheit heißt Retinitis pigmentosa, das heißt eine Lichtwahrnehmung mehr. Mobilität für einen nicht sehenden Menschen ist äußerst problematisch. Um sich überhaupt in Verkehrsflächen bewegen zu können, ist einfach der Langstock das Standardwerkzeug, um auch Hindernisse entsprechend wahrnehmen zu können. Man hat als Nichtsehender, der keine Lichtwahrnehmung mehr hat, natürlich keinerlei Möglichkeiten, sich zu orientieren, und die Gefahr des Verlaufens ist doch sehr stark gegeben.
A new technology could soon help them find their way more easily in urban environments.
How many blind people are there? If you don't know many blind people, it might be easy to think the number of blind people in the world is pretty small, but the figures might surprise you. According to the World Health Organization, about 285 million people are visually impaired worldwide.
How can we help? Obstacle detection for visually impaired people.
In today's world, even the physically well person faces the challenges in navigating to the right location without technology. Our main goal to choose this project is to help the visually impaired people to discover the objects around them and help them in navigating to avoid the obstacles. Our product acts as a first step in achieving that goal. Let's look at our product implementation. The model uses low-cost Esp32 microcontroller with inbuilt camera, ultrasonic sensor to measure the distance, and buzzers for actuation.
We have used Arduino to program our microcontrollers and buzzers. The hardware is programmed to capture the image when an object is close by. The image is then sent to FTP server through a client. To identify the objects in the image, we are using Google Vision API. The inputs to this API is sent through this getImage call, which will send the image details to the API. The image API is connected to the Lambda function, which gets triggered as soon as the image gets uploaded to the FTP server. The response from the Vision API is modified to get the directions and the number of steps that a person has to move. The response can be seen from the screen, which is then sent to DynamoDB. The API runs in loop to check if any new objects are detected. As soon as an object is observed, it instructs the person with the buzzer. The left buzzer beeps when an object is in left and right when the object is in right. The response from the API is logged in DynamoDB, which is saved for future work.
The response from the DB is utilized in this Android application, through a Get API, where the response is then converted to speech. What you see is the Object Detector Android application. For testing purpose we have taken a random image. As you can see, the response instructs the user in his directions.
Dog is in front of you. Please take one step towards left and continue walking. Bicycle wheel is in front of you. Please take 2 steps towards right and continue walking. Furniture is in front of you. Please take 1 step towards right and continue walking. Person is in front of you. Please take 1 step towards left and continue walking.